Welcome to Scientific Thoughts with new interesting episode. A supervolcano is one that can destroy entire continents, erupting every 600,000 to 800,000 years and causing widespread devastation. Recently, Yellowstone National Park has shown unusual geological activity, putting experts on high alert. Reports have noted hundreds of earthquakes and a rapidly rising, dome-shaped uplift, raising serious concerns about the supervolcano beneath the park. Could these signs indicate an impending eruption? What forces are at play beneath the park's surface? Let's delve into Yellowstone's latest seismic events and uncover the truth behind this alarming situation. Yellowstone's history is rich and fascinating, filled with stories of early exploration and its unique geological features. Before it became a national park, Native American tribes like the Crow, Shoshone, and Blackfeet lived in the area. They used the park's geothermal features for cooking and healing and had a deep respect for its natural power. European American exploration didn't begin until the early 19th century. The famous Lewis and Clark expedition of 1804 to 1806, although not directly exploring Yellowstone, sparked interest in the American West. The first documented exploration of Yellowstone by non-Native Americans was the Cook-Folsom-Peterson expedition in 1869. This small expedition revealed the wonders of Yellowstone to the world, documenting its geysers, hot springs, and stunning scenery. The Hayden Geological Survey of 1871, led by geologist Ferdinand Hayden, was crucial. This federally funded expedition surveyed and documented Yellowstone's features in detail, capturing the public's imagination and convincing Congress to protect the area. In 1872, President Ulysses S. Grant signed the act establishing Yellowstone as the world's first national park, aiming to preserve its unique features for future generations. Yellowstone is a geological treasure trove, famous for its geysers, hot springs, and other thermal features. Old Faithful, the most renowned geyser in the world, erupts every 60 to 90 minutes, captivating visitors. The park is home to about 10,000 thermal features, including the colorful Grand Prismatic Spring. Beneath Yellowstone lies the Yellowstone Caldera, one of the largest active volcanic systems in the world. This supervolcano has erupted 3 times in the past 2.1 million years, with each eruption being thousands of times more powerful than typical volcanic eruptions. Yellowstone's geothermal and tectonic forces create a dynamic and ever-changing environment, making it a focus of scientific research. Understanding its geological activity is crucial as it helps us learn about the powerful forces shaping our planet. Recently, Yellowstone has experienced a significant increase in seismic activity, raising concerns among scientists and the public. Hundreds of minor earthquakes have occurred in just a few months, forming a pattern that has scientists on high alert. Historically, Yellowstone sees between 1,500 and 2,500 quakes annually, most of them too small to be felt. However, in some years, like 2017, the number skyrocketed, with over 3,400 reported events. Scientists rely on a network of monitoring tools to keep a close watch on Yellowstone's seismic activity. The U.S. Geological Survey, USGS, and the Yellowstone Volcano Observatory, YVO, play crucial roles. They use seismographs to measure and record the vibrations of the Earth and GPS stations to track movements in the Earth's crust. Satellite imagery also helps detect changes in the landscape, such as the rapid uplift of the ground. Recent data shows that earthquake swarms are concentrated around the Norris Geyser Basin and Yellowstone Lake, areas known for their geothermal activity. This suggests a strong link between the earthquakes and magma movement beneath the surface. However, predicting exactly when and where an earthquake or volcanic eruption will occur remains challenging due to the complex and unpredictable nature of Earth's processes. An alarming development is the discovery of a rapidly expanding, dome-shaped uplift in Yellowstone, indicating significant geological changes beneath the surface. Using advanced satellite imagery and precise ground-based GPS measurements, researchers have found that the ground in specific areas is rising at an alarming rate. This suggests that magma is moving closer to the surface, creating pressure that causes the ground to bulge. The presence of this uplift indicates intense magmatic activity beneath the surface and could be a precursor to a major volcanic event. However, predicting such events is difficult due to the complex nature of the Earth's crust. continued monitoring and research are essential to understanding the potential risks and preparing for future events. In addition to geological changes, wildlife in Yellowstone has been acting strangely. Bison, elk, deer, and birds have been displaying unusual behaviors, such as moving away from the park center and venturing into atypical areas. Animals are known to sense environmental changes that humans often overlook, and their behaviors could signal an upcoming geological event. Historically, animals have acted as natural early warning systems, detecting underground tremors and gas emissions before humans can. These recent developments in Yellowstone highlight the importance of ongoing scientific research and monitoring to understand the powerful forces at play and prepare for potential risks. There are many stories of animals acting strangely before major geological events. Indigenous tribes, living in harmony with nature for thousands of years, have shared these behaviors in their oral traditions. In Yellowstone, tribes like the Shoshone and Blackfeet have told stories of animals fleeing the area before eruptions and earthquakes. These tales highlight the deep connection between wildlife behavior and environmental changes. One well-known example is the 1980 eruption of Mount St. Helens. In the days before the eruption, wildlife began behaving oddly. Deer and elk moved to lower elevations, and birds changed their flight patterns. These changes were later understood as responses to the geological activity brewing beneath the surface. Similar behaviors in Yellowstone suggest that animals might be sensing something we cannot yet fully understand. While predicting geological events with certainty is difficult, unusual animal behaviors indicate something is amiss. Recent seismic activity and a rapidly expanding dome-shaped uplift suggest Yellowstone's geological system is becoming more active. Could the animals be sensing an impending eruption or another significant event? Scientists are closely monitoring the situation and paying attention to these natural early warning systems. The behavior of Yellowstone's wildlife could provide valuable clues about underlying geological processes. By studying these patterns, researchers hope to gain a better understanding of what might come next. The thought of the Yellowstone supervolcano erupting is chilling. While such an event is rare, understanding potential scenarios and their consequences is crucial. A supervolcano eruption at Yellowstone would be catastrophic. The initial explosion would unleash pyroclastic flows, fast-moving currents of hot gas and volcanic matter that could incinerate everything within a 40-mile radius. These flows move at speeds up to 450 miles per hour and reach temperatures around 1,000 degrees Fahrenheit. The eruption would also spew vast amounts of ash into the atmosphere, spreading across the continent. Major cities like Denver, Salt Lake City, and even New York and Los Angeles could be covered in volcanic ash. This ash is not just a nuisance, it is abrasive, acidic, and toxic, posing severe health risks, contaminating water sources, and making agriculture difficult. The long-term effects would be dire. The ash and gases released into the atmosphere would impact global climate. Sulfur dioxide would form sulfuric acid aerosols, reflecting sunlight and leading to a significant cooling of the Earth's surface, known as a volcanic winter. This could drop global temperatures by 5 to 10 degrees Celsius, causing widespread crop failures, food shortages, and even famine. Additionally, the eruption would release large amounts of carbon dioxide and other greenhouse gases, contributing to long-term climate change. The environmental impact would be global, altering weather patterns and affecting ecosystems far beyond Yellowstone. To understand the potential threat, we look at Yellowstone's past eruptions. The supervolcano has erupted 3 times in the last 2.1 million years, each time with devastating effects. The most recent eruption, about 640,000 years ago, ejected over 1,000 cubic kilometers of volcanic material, more than 1,000 times the volume of the 1980 Mount St. Helens eruption. These historical eruptions caused global temperatures to plummet, affecting climates worldwide. Yellowstone's potential eruptions dwarf most other volcanic events in recorded history. For instance, the eruption of Mount Vesuvius in 79 AD, which buried the cities of Pompeii and Herculaneum, was minuscule compared to Yellowstone's potential. Even the eruption of Krakatoa in 1883, which caused dramatic sunsets worldwide and lowered global temperatures, pales in comparison to the supervolcano's power. As Yellowstone shows signs of unusual activity, preparedness and mitigation efforts are critical. The Yellowstone Volcano Observatory, YVO, works with various organizations to develop robust monitoring and early warning systems. These include seismographs, GPS stations, and satellite monitoring tools to detect seismic activity, ground deformation, and gas emissions. Clear evacuation plans and detailed routes have been mapped out, and emergency response teams are trained to mobilize swiftly. Public awareness and education campaigns ensure residents and visitors understand the risks and know how to stay safe. In the digital age, staying informed is easier than ever. Online resources and apps provide real-time updates on Yellowstone's geological activity. The YVO website offers detailed reports and live data feeds, while mobile apps can send alerts directly to users' phones. Following official social media accounts and subscribing to alert services helps people stay up to date with the latest developments. Understanding Yellowstone's geological activity is crucial. By staying informed, being prepared, and understanding the risks, we can minimize the impact of any geological events. Scientists and officials must remain vigilant, constantly monitoring and studying the park to protect both the environment and the surrounding communities. Thanks for watching Scientific Thoughts Today episode. Keep watching and stay tuned for more interesting episodes. Subscribe and like our channel. Have a good day.